What's up, my friend? What is up? What's up? What's up? What's up? What's up? Okay, so last time we talked about protocols and services. We're going to finish up the second part of the same topic. We've got a few more that you need to know: NetBIOS, DNS, IMAP, SMTP, a few others. And tomorrow we're going to dig into wireless. So let's jump right into this because I have a lot to cover. The main thing you need to know are these port numbers and the corresponding services. You really need to know that by heart. You need to memorize it. So take the time to write this down to memorize all these ports, okay? And the acronyms. So the first thing I'm going to tell you about is NetBIOS, Network Basic Input Output System. It uses UDP ports 137, 138, and TCP port 139. Now, it's a legacy protocol. You know, it was used by Microsoft in the early days for internal name resolution. So if you had a host name on your LAN and you needed to find the IP, you would use NetBIOS for that. It's been supplanted by DNS, the domain name system, which is a hierarchical name lookup system that's used on the internet, and it's modern, it's robust, and it's pretty much taken the place of NetBIOS for the most part in most organizations. DNS uses UDP port 53 to facilitate the exchange of what's known as DNS queries and DNS answers. So the way it works is you have a client, you open up your browser, you type in fixedbyvanya.com, you're issuing a DNS query to a DNS server. The DNS server then looks to find the corresponding IP address for fixedbyvanya.com in its database, which is known as a zone file, or a zone, just a zone. And if it has it, it'll return that answer with the IP address. Now, the IP address in most cases is an IPv4 address, and that is why that record type is called an A record. So let me show you the different record types you need to know for this test. There's about 5 of them. And the A records are the most common. So an A record maps an IP address, an IPv4 address, to a host name. That's all it does. It's actually called an A record. It's a 32-bit IPv4 address. Try to guess what a quad A record does. Quad A. What do you think that does? Yeah, yes, you have it. That is exactly what it does. A quad A maps an IPv6 address. Now, why is it 4 A's and not 1? Yep, because, because each A is 32 bits, right? So 32 times 4 is 128, which is precisely the number of bits allocated to IPv6. So that's how you can remember the difference between the two. So the A record is also known, I forgot to mention, the A record is also known as a forward lookup, okay? And that's because you're basically looking for the IP address that matches the host name. If you go the opposite direction where you're looking for the host name that matches an IP address, that's a reverse lookup. And those are stored in a zone file as a PTR, or a pointer record. Okay, so PTRs are reverse lookups, A records are forward lookups. The MX record, a mail exchanger, is a record for mail servers, right? So mail servers have host names as well, and they need to be resolved into IP addresses to facilitate the exchange of email. And so they have their own record types, mail exchanger records, MX. And then you have the CNAME record, the canonical name, which is just an alias. It's another name, or another, I said name a lot, but it's another word to represent a host on the internet. All right, so we've got those out of the way. DNS uses UDP port 53 for these queries. It uses TCP port 53 for zone transfer. So some organizations will have multiple DNS servers on the LAN, and they will permit the transfer of these zone files between trusted DNS servers. That's fine, but it should never be allowed to execute a zone transfer request from a machine on the internet, right? So if you're on the internet and you're trying to execute a zone transfer, it should fail every time. That's because attackers often use zone transfers as a first step for device enumeration, host discovery. It's not good. You should never have it enabled on the internet, okay? Now, what else do we have here? So we've got DNS. We have, what do I want to go next? We talked about IPv4. We talked about IPv6. We could talk about some of the Aml protocols. So you have SMTP, the Simple Mail Transfer Protocol, which uses TCP port 25. You have POP3, the Post Office Protocol version 3, which uses TCP port 110. You also have the Internet Message Access Protocol version 4, IMAP 4, which uses TCP port 143. And that is it for the mail protocols. There is another standard that is kind of gaining some popularity these days. So there's the Small Computer Systems Interface, the SCSI format, which has been around for decades. But the iSCSI implementation of it, the Internet Small Computer Systems Interface, is gaining some headway because you're basically able to use Fiber Channel, which is the technology that was traditionally used to transfer lots of data at a very high speed. But you can use fiber channel over Ethernet, FCOE. And that's why it's getting popularity, because you don't have to use the specialized cables and connectors and architecture that network administrators and architects had to use in the past. You can just use the Ethernet standard, which is a lot cheaper. It's easier to come by, and that's why FCOE, fiber channel over Ethernet, is gaining standard for this iSCSI. It's gaining popularity. Man, I can't talk. I hope I'm making some kind of sense. Man, it's really hot in my truck, and I'm struggling to keep myself from melting. And that sound you hear in the background is the air conditioning. And the only other thing you need to know about is RDP, Remote Desktop Protocol. It uses TCP and UDP ports 3389, all right? So tomorrow we are going to dig into Wi-Fi. We are actually we're almost approaching the end of this network security domain. So be on the lookout tomorrow for Wi-Fi. We just have a few videos left in that, and then we're going to move into a few other domains, okay? So make sure you thumb this video up, leave a comment, hit that subscribe button, hit it. That way you can be the first to know when the new videos drop, and I want to make sure you're down with that. I think that's it. Yeah, so let me just end this video now. I'll see you tomorrow at 8 a.m. Eastern and 7 a.m. Central. Bye.